Hi everyone. In this video, you are going to learn memory allocation in stack and heap. We are going to learn how memory gets allocated and what are operations happening in stack and heap. So let's go. The memory that is assigned to any program or application is divided into four segments: heap, stack, static or global code. Heap contains blocks of memory. Using dynamic memory allocation, we are going to use the blocks of memory. Function calls and local variables will be in stack, whereas static or global segments contains global variables. Global variables are nothing but the variables that can be accessed from anywhere of the program. Code contains instructions. Dynamic memory allocation can be done by malloc, calloc, and realloc. Deallocation is done by free function. When the program starts, operating system allocates size for stack, allocation of stack frame and local variables happens at runtime. Here is a diagrammatic representation of stack, where yellow mark represents stack frame. When function is called, it is pushed into stack. After its job, it gets popped. Here is a simple program to illustrate memory allocation in stack and heap. This is a program to add and subtract two numbers. As we all know that the execution of the program starts from main. As soon as the control gets into main function from the OS, it is pushed into stack. Here A and B are local variables which are pointing to an integer. We will call it as pointer variables also. Using malloc, I am allocating size for A and B. Malloc returns the address of that specified block and stores in A and B. I'll show it diagrammatically. As I said, stack contains function calls and local variables. So main function is pushed into stack. Here A and B are pointer variables pointing to blocks of memory of address 200 and 500 respectively. Here we found printf function, which is a built-in function included in stdio.h. So main gets paused and printf is pushed into stack and gets resumed. I will show it. After encountering printf function, it is pushed into stack, it displays the message and returns the control back to main. It is shown with an arrow in the first diagrammatic representation of stack. The second diagram represents the final state of stack after it returns the control. Now the control is in 11th line. Through scanf, I am accepting the values of A and B. Here we found another function, add function. It is passing two values but not the address. Here add function stack frame contains three local variables A, B and C. We are passing A and B from main, so it is stored in stack frame. Here C is calculated by simply using assignment operator. So the value is 8. Now C gets passed into display function. Add function gets paused and display function gets resumed. Wait, I will show it. See in the second diagram, add function gets paused and display function is resumed. As we found another printf function in add function. Display gets paused and printf is pushed into stack. It displays the message and control gets back to display function. So display is resumed now. As it encountered close braces, the control gets back to add and add function also gets popped. It is shown in second diagrammatic representation of stack and heap. In line 14, it found another function sub. So main gets paused and subfunction is pushed into stack and gets resumed. Function stack frame contains or consists of three local variables a, b and c. We have passed the values a and b from main. C gets calculated by using assignment operator. So the result is 2. As it encountered display function, it is pushed into stack by parsing subfunction. As we found another printf function, display get parsed and printf is pushed into stack. It displays the message and control gets back into display function. Wait, I will show it diagrammatically. Here you can see that display gets parsed and printf is pushed into stack. After it's displaying the message, the control all the way goes to display, and after encountering closed braces in display, it again returns the control to subfunction, where in subfunction also it encountered uh, closed braces. Wait, I'll show it. See here. Now here we encounter return state. So the control is returned back to OS by popping main function. Finally, stack gets empty but not heap. So we need to free by using free function, else garbage is collected. If we don't free it in large programs or games, lots of memory gets wasted. So we need to free. That's all for this video. Thank you for watching.